The continuous function f is defined on the interval from -2 to 5, and again we've been given a graph, and this graph happens to be the derivative of a function g. And what we're being asked is find the critical points and determine whether they are max, min, or neither, and this is on the function g of x. So what we want to do then is we want to find where it crosses the x-axis. So that where it crosses the x-axis, those represent the points where those represent our critical points. So at -1, we have a slope of 0. At +1/2, we have a slope of 0 as well. We want the positive slope is where the y-coordinate of the derivative is positive. And so we have positive slope through here. We have our 0 slope through here. And then between -1 and +1/2, the y-coordinate is negative. So that means it's sloping down through that point, through that interval. Okay, so that -1 represents a max point. From +1/2 to all the way to 5, it's all in the f graph, or the g prime is all positive. So all the way to the endpoint, it's going to be sloping up. Okay, and our endpoints are 5 and -2. So at -1, x equals -1 is a max, and at x equals +1/2, that represents a minimum. So in this case here, we've been given some coordinates that g of 1 is equal to -2, and we're being asked to find the values at the critical points and determine the absolute min and max of the interval of g from -2 to 5. Okay, so we're finding the values of g. To find the values of g, so I'm going to calculate values of g. The values of g are in general going to be equal to some starting point at x equals a plus the area under the curve from a to x. Okay, area under the g prime function. In this case, the area under f. So to find the value, so we're going to first start at g of -2. That's an endpoint. So at x equals -2, we need to find a g coordinate. We're going to find that by starting at g of 1. So that value is equal to -2 plus the area under the curve from 1 all the way to -2. I'm just going to change that to f because that g prime and f are the same. So calculating that value, we end up with -2 plus the area under the curve from 1 to -2. So from 1 to -2, we're starting at 1, and we're going to integrate in this direction. So we know that this area under the curve is going to be negative. So that's going to be, looks like -0.75. This area here is 0.25. Again, we could just eliminate those two yellow areas, and although we can calculate this area as 0.5, we know that those two areas also are going to cancel out here and here. Okay, so this is going to be, we're going to have pause, and I have my sign incorrect here. Since it's below the x-axis, that area is going to be positive. The displacement will be positive 0.75. These two together give us negative 0.75. So the net displacement is, in long-winded terms, it's 0. Okay, because the area above and below are equal. So the y-coordinate is going to be negative 2. Okay, so we have that point at negative 1. We're going to calculate g of negative 1. Okay, that looks to be a local max in this point here. And again, we're going to start at negative 2. And then we're going to add in the area under the derivative from 1 to negative 1. Okay, so that area from 1 to negative 1, if we take a look at that area, we have positive, let's clean this up here, we have negative 0.15 up here. Okay, so that area in here, sorry, negative 0.25, since it's above, and from positive 1/2 to negative 1, that area is going to be positive 0.75. So we have an net area of 0.5. So working out that coordinate then, that's going to be negative 2 plus, it works out to be a positive area of 0.5. Okay, so that works out to be negative 1.5 is a coordinate. So at negative 1, we're going to have negative 1.5. And that looks like it's going to be our max. So we still do have to test our value at 5. So we're going to do the rest of these. We have our 1/2. So we're going to do g of 1/2 first. And again, we're going to start at negative 2 plus the area under that graph from 1 to 0.5. Okay, so that area, again, we are integrating from right to left, so that area is going to be negative 0.25. So negative 2 plus negative 0.25, and that works out to be negative 2.25. Okay, so that looks like it's our min. Now, lastly, we just have to do g of 5. G of 5, the endpoint is going to be negative 2 plus the area under that curve from 1. In this case, now we're integrating from left to right. Okay, so the area above that is going to be, above is positive and below is negative. Okay, so taking a look at this area in here, we want to find this trapezoidal area. Okay, so that trapezoidal area happens to be positive 2 units. We also want to find this semicircular area. So that's going to be, I'm going to start with my square of 9, and I'm going to take away, okay, pi r squared, so 9 pi, a quarter of that, so I'm going to take away 9 pi over 4. So the area that I'm looking for, I'm just going to shade that in green here, that's going to be, that area in here is going to be, we're going to start with 9, and we're going to take away 9 pi over 4 to get the green shaded area. Okay, so that net area is going to be 11 minus 9 pi over 4. So we're going to have negative 2 plus, since it's all above, 11 minus 9 pi over 4. So that value works out to be 9 minus 9 pi over 4. And that is likely going to be our max point. So let's just work that out. 9 minus 9 pi divided by 4 gives us 1.93, positive 1.93. So this is a positive value. So this represents the absolute max. And then the lowest point is going to be this point in here, which is our local min, but also happens to be our absolute min.